Hi guys, I know some of you have been struggling a little bit with the electronic structure, which was chapter 1 lesson 7, so hopefully you had watched that video. So the things that we need to know are how many electrons can the first energy level hold? Well, the first energy level can hold 2, the second can hold 8. Now some of you might have looked a little bit further and seen that actually this isn't 100% true, but for our intents and purposes, the third can hold 8, and we only fill we only ever fill to 2 for the fourth energy level. It can hold more than that, but we never go beyond that because we only need to learn up to calcium. So that gives us 20 electrons, which would give us the first 20 elements. How many electrons does helium have? It only has 2. Lithium has 3 electrons. How many shells does it need to fit all of its electrons? It needs 2. Does the number of electrons in the outer shell tell you the group number or the period? It tells you the group, which is really helpful because that means that if you look at the group number, you know how many electrons are on the outer shell, and then draw the energy levels for carbon. Well, we would hopefully, I'll need to move that up for you. Hopefully we would have noticed that carbon has 6 electrons, so we're going to fill from the middle and go out, going up a level once the level that we're doing is full. So there's 1, 2 on that first level. It doesn't actually matter where around this circle you put them, but it's convenient if you put them sort of nice and clearly. So I will always put them at the top, bottom, left and then right, and then they'll pair up. So we then have 1, 2, 3, 4 for carbon, and that's it. Okay. On this one, we need to have a little bit of a further go, but basically all we're needing to do is look on the periodic table and see how many electrons it's got, and then fill it in, remembering that we only go up a shell or an energy level when the one below is full. So we've got hydrogen over here with 1 electron, helium has 2 electrons, so we've got that, and here we're showing as well the electron configuration, a written way of showing it. So this is saying that there's only 1 electron, this is saying that there are 2 electrons and they're both in the first shell. This is saying that lithium, it's already given you a hint, that there's 2 on the first shell and then 1 on the second shell. So we go 1, 2, 3. And that's our 3. 2 on the first and then 1 on the next. Okay? It's really important that you make this nice and clear. Okay, that's why I put them at the top and the bottom and the left and the right. Okay, so beryllium has 4 electrons in total, so 1, 2, 3, 4, and that would be 2, 2. Boron has 5, so that would be 1, 2, 1, 2, 3, so that would be 2, 3, so giving us our 5 in total. Carbon we drew just, so 1, 2, 3, 4, 5, 6, so that would be 2, 4. Nitrogen has 7 electrons, so 1, 2, and then 1, 2, 3, 4, and 5, so 2, 5. Oxygen has 1, 2, 3, 4, 5, 6, 7, 8 in total, so 2, 6. Fluorine has 9 in total, 1, 2, 3, 4, 5, 6, 7, 8, 9. 2, 7. And then neon has 10, so 1, 2, 3, 4, 5, 6, 7, 8. So 2, 8. If we go back over here, so now we don't know what these are, although you might have noticed that they're laid out in the same way as the periodic table. So we then have potassium. So I'm just going to put the symbol there. So potassium, that has 19 in total. So, no, sorry, I went ahead a row. Sodium, and that has 11 in total. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 2, 8, 1. Then we have magnesium, and that's got 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, so 2, 8, 2. You might possibly have noticed that there is a pattern that it goes up 1 each atom across, and then all of these have their first shell full. All of these will have their first and second shell full. So we need to go over to aluminium, and that's got 13, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, so 2, 8, 3, and then we are on silicon, so 1, 2, sorry, yes, I give you the symbol, so 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 1, 2, 3, 4, 2, 8, 4. We then have 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, and then 1 extra, and sorry, that one was phosphorus, so P. We then come to sulfur, so I'll pop it over there, and that one was 2, 8, 5, so 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, so 2, 8, 6, and then we are on to chlorine, and we've got 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 2, 3, 4, 5, 6, 7, so 2, 8, 7. Sorry. Then we are on to argon, and we've got 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, so 2, 8, 8. We're now down to potassium, and we've got 19, so 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, so 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. And then we're at calcium lastly, and that's our 20th element. That's how far we need to be able to take this. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. We'll pair them up. And we've got this one is 2, 8, 8, 1, 2, 8, 8, 2. Putting a comma in between each. And you'll notice that these all have 1 electron in their outer shell. Group 1 will have 2, group 2 will have 3, group 3, group 4 will have 4, group 5 have 5, group 6 has 6, group 7 have 7. Group 8 is also known as group 0, because obviously helium only has 2 electrons in its outer shell, so it doesn't have 8. But if we looked at the shell above, there are no more in the shell above. It's completely full. Okay, hopefully that helps make sense of everything.